So I just wanted to talk a little bit about how we package the product and the different editions of the product. So today, basically what we have is, so we have three editions of the product essentially, and then we have a number of control modules on top of that.
John?
Thank you. So today we have a free offering that we call the Virtual Health Monitor. And again, this is all built on the same underlying product foundation. And the free Virtual Health Monitor today offers really basic monitoring and reporting, identifying the risks that you have in your environment. So obviously, as part of doing what we do, we identify the risks and the inefficiencies in your environment. We know the specific actions through what Shmuel talked about in terms of how to drive your environment to the desired state. But with the free product, we're identifying those risks, but we're not giving you the actions or the automation to get you into that desired state. But what we do in the free product is, again, identify those issues, but also we provide a kind of a weekly report that tells you, if you actually applied, if you went up to the full VMTurbo product, here's the additional efficiencies you'd gain, here's the risks that would go away because you apply our automation and our analytics, and we can actually quantify that because, again, we're not just looking at the current risk and the current efficiency. We understand through the application of our actions where you can actually get to from an efficiency and a risk perspective. And so we can quantify that, right? We can quantify that in terms of, here's the VM density improvements you should expect by applying our engine. Here's the risks that we can fix and go away through the application of our automation. And so we essentially upsell you from the free to the full Operations Manager product. And then we have a couple of editions here. The Enterprise Edition, Operations Manager Enterprise Edition, which is really the flagship product that has the control system that we talked about, being able to assure performance, being able to drive up efficiency, the capacity planning, access to our APIs as well. We have a RESTful API that you can access through the product. And then we have a Cloud Edition that adds support for things like we talked about, Cloud Stack, vCloud Director, allowing you to kind of carve out those multi-tenant views for service providers and those offering infrastructure as a service, whether it be in the enterprise or on a provider side. And then on top of that, we have a number of what we call control modules that really extend what Shmuel talked about into the different areas of the IT stack. So we added a storage control module last year that goes into the NetApp infrastructure, and we're working on EMC currently, to be able to control the underlying arrays and add that into those desired states that Shmuel talked about. We have an application control module. We just announced fairly recently a fabric control module, so with support for Cisco UCS. So the ability now to spin up blades on demand, as an elastic kind of compute resource, giving you recommendations on not just compute but on bandwidth. How many network ports do you need to configure to maintain performance as well and while driving up efficiency. So this is kind of how we package the product. It starts at $8.99 a socket today, and the control modules start at around $1.99 a socket, and we have various different bundles of those things. But I think one of the things to remember is, the ROI and the value that people are deriving from this, again, is because we can go in and say, hey, we're able to increase your VM density by 20 or 30%. That equates to, oftentimes we'll go in and there's a project associated with it or something, or they're trying to deploy a new application, and we can actually, they may not even have to buy any new hardware at all because we've driven up that efficiency. So it's a very simple ROI typically when we go in with the product. And obviously also the operational gains, right? It's a little bit like, when virtualization started, you get in with the capital efficiencies, but the reason it stays in is because of the operational efficiencies, right, and the benefits.
One of the things you got there, I mean, I love flat socket modeling. Like, that's the greatest way to go. I don't have to think of it like a gym membership and predict how I'm gonna, consume it and cost it out.
Right.
Interesting when you talked about being able to do bare metal provisioning as part of the control engine. When you do that, I'm assuming you mean as like guest consumption of those versus spinning up another compute platform, because ultimately that blows out your licensing, because then how would you manage that one, and do you guys cover for that? So say literally a self-expanding compute platform, but suddenly you're deploying more hypervisors using the product itself.
True, that's true, but you'd probably buy based on kind of your expected use. But we do with the fabric control module now have the ability to spin up new blades on UCS. So it is important that this is not just bouncing stuff around, it's actually adding capacity and removing capacity. You know, Yuri might even touch on the hybrid cloud thing where, you know, we can actually make decisions around, well, maybe we need to add some capacity. If you have a hybrid cloud model, maybe you need to burst into the cloud, those kind of things. So, and that's, you know, being able to add and remove capacity is a big important part of being able to stay in that desired state. And, you know, what we're seeing now with the ability to define everything in software, right, is that a lot of these things are just software decisions, but how do we make the right decisions to kind of drive that? And, you know, with things like UCS is a very advanced platform, fortunately, that has these open APIs that we can use to do things like that. And I think you'll see that continue right across the ecosystem as well. So,
like with that deployment engine for the bare metal deployments, do you just leverage other tools that are already out there? Like obviously UCS has their own platform for blowing images straight on.
Right.
What if you were you know, implementing Razor, you know, as your in-house tool? Like, do you guys adaptively just tie into other products, or do you yourself have your own provisioning engine to write back to bare metal?
Typically we'll tie in with other products, but you know, as part of as Shmuel decided, part of that common model, it's really just the model stays the same as a common abstraction. It's just switching out a particular mediation underneath, but we typically leverage the mediation from
you just basically have a southbound API that ties into their northbound. There's a lot of norths and souths that are in that layer, right?
Right. You produce the interface between those two pieces. It's not like you document how your side works. I like the auto provisioning of the virtualization host, because that means you can load balance across multiple vSphere clusters. And so this cluster needs to shrink so that this cluster can expand, because the cost has gone up in this cluster, but not in this. You know, it's low. It's high in the cluster where the host is going to go to, and low in the cluster that's sourced from. That's
right.
You know, when you've got 10,000 hosts, that kind of construct's going to be crucial.
Yeah. That's actually something we're seeing quite a bit with customers now, is that ability to do this across clusters. So we're actually working with a customer recently, and you know, we could actually, they you know, and obviously with things like NSX and now and the ability to stitch all these things together, they actually found out that they could actually using our solution, they could get rid of an entire cluster. It's because what's happened with clusters is kind of like what happened before virtualization, right? We've got these artificial kind of silos that are highly, in many cases, I had to deploy VM over here because it had to go in this cluster, but now you've got these imbalances in utilization that now, using our solution, we can you look at the whole pool, right, and to do that. So
also a heterogeneous pool. For example, you have a VMware cluster and an Hyper-V cluster. You try to put the business critical application on the VMware cluster, and found if some application could be considered to migrated to other type of cluster.
Yeah, we can certainly do those use cases and set up policies. So,
pricing maybe.
Right.
Okay.
Yeah.
Cost of.
That's one of the popular cases, especially we're working with Microsoft, and for them, it's a very important case, because they do want to encourage people to move the load to Hyper-V, and we actually help them to do exactly what.
Right, but you're right. For the service, even if you generalize your question from not just VMware Hyper-V, in a service provider, if you step back from all the details, what do you have? You have a class of consumers, and you have a class of suppliers. Exactly. And if you can prioritize the consumers by giving different consumers different budgets,
different profiles,
and you can prioritize the providers or the supply by giving different cost structure to the different supplies that you have there, now you have a system that can just make the right decision which consumer should consume which provider. And that's what we have here. Because the basic engine at the top of the supply chain, each entity gets a budget. By default, when we ship, every entity gets the same budget. And at the bottom of the supply chain, the commodities has some arbitrary cost. But you can come in and control those, and by doing it, accomplish any of those use cases that you can distinguish between classes of consumers and classes of providers.
Same apply for storage, for example. You have different type of storage, different hosts.
Storage
between EMC and NetApp, you may decide what is more economical and performing.
And you can then compound with it. You can actually, any compliance that you may have in your environment can become a commodity that you are trading and associate costs with that, because you can say, oh, I have a compliance. I'll take a simple licensing compliance. Yeah. Okay, I can run up to 10 instances here on a VM, on a host. Okay, fine. So now the license itself becomes a commodity that is being traded and being priced in the market.
Who decides of the cost, you know, of EMC versus NetApp, or because that could be quite difficult to, you know, put a figure against? So by
default, you don't. So typical customer doesn't deal with that. Okay, they take the out of the box. But there is on the bottom of the supply chain, you can provide cost for entities.
Plug it in and
use it. It sounds like a service catalog model with, you know, gold, silver, bronze, but fully automated.
Pretty much.
Right.
Pretty much.
Just to make sure I understand, so if you put in those financial numbers, it could help you to make the decision to move between vSphere and Hyper-V or vice versa?
Correct.
Could it actually use the load for you, or would you do that manually?
So we are not necessarily in the business of converting a vSphere image to an Hyper-V compliant image. If there are tools that do it, we'll generate the recommendation to move from Hyper-V to VMware or vice versa, and then we'll call a tool that is able to do it. We are, if you notice, our key value, if you want, is in the brain to make the decision. And we'll tie ourselves to whatever instrumentation and controls that is exposed by the environment that is available. And what we ship in the market relies on what's available off the shelf commercially by either from the different vendors or some standard like JMX and WMI. But yeah, so we are trying to minimize, if you want, us doing plumbing and relying on other people providing the plumbing.
And then, by the same token, could the tool help you to decide to move, say, to the public cloud, or move from AWS to
Azure?
To Azure?
Yeah. Yes. Yeah. That's exactly one of the cases.
Yeah. When we started the company, my pitch was to the investors that in 2015 we raised the money in 2008. Well, February of 2009. But I made that pitch in 2008. Is that in 2015, workload will be mobile across the universe. And when that happened, the hardest, most important, difficult question that enterprises will be left with is the question that I call WWW, what, where, when. What workload to run where and when to maximize the ROI from whatever compute capacity you can acquire on demand. And that engine was designed to answer that question. And obviously where the market is, we implemented it first to manage your internal IT. But the idea is that as workload become mobile and more transparently mobile, take advantage of that and make the right decision to maximize the ROI.
Very cool.
Yep.
So can I ask one more question? So for vSphere, for example, would you rely on Orchestrator in that case, or would you bypass, or would you rely on a tool like that, or go directly into the API via your own calls to vSphere?
Yeah, we generally go directly into vSphere, we generally rely on the underlying primitives that are exposed in either the hypervisor or the cloud management platform. So we probably wouldn't create our own vCenter orchestrator scripts unless we really had to. I don't think we do that.
If you remember, Shmuel presented 4 typical type of actions you have. Move, size up, size down, start and stop. All platforms we support these actions. And by default, we use these actions directly. The need for platforms like VCAG or orchestrators is when you have some specific enterprise-specific policies, so change control, where you really need to do something before to take the action. This is usually the cases where we may want to integrate. But out of the box, by default, all our actions are supported directly with the capabilities of the target platform.
Okay, cool.
Cool. Any other questions?
You work with platform as a service, anything OpenShift, Cloud Foundry, anything like that? You have modules for spinning up new broker nodes, anything like?
That's one of the technologies we are looking at, and today, as you know, platform as a service this area is actively being developed.
Right. But there are products out there like Red
Cloud
Hat.
Foundry. Yes, there are. We are watching it very carefully, because once this approach is adopted widely, our technology could be applied to many cases, especially for application management.
Yeah, I mean, that's where I see a good value with this, is that as nodes are needed for platform, I mean, those are all, bare metal builds, and then if you need virtual resources for some of the delivery mechanisms that are in the virtualized layer, there's those two components that are going to be very closely tied to scale the environment out.
Correct.
I mean, I think one thing to kind of realize from what I described here, that we implemented a very specific, if you want, abstracted but still specific supply chain for the virtualized stack. That in that supply chain you have VMs and virtual data center and whatever, but nothing in the system actually bind us to that type of containers or containers. Yeah. And as containers evolves and different type of containers, and the VM becomes bundled with some other containers or whatever, we are very well set to say, okay, my supply chain is now just go, this is the container, and this is the bare metal that is running on, and that's it. And that's my supply chain, and I make decisions about that container and the application that runs in that container, and nothing ties us specifically to the current virtual hypervisor layer.
So you can create these logical constructs too.
Right.
Okay. Right. Yeah. Right. And that's a way for us to support PaaS. That's
okay.